16, 17, and 18, I can no longer rewrite these with the same base. I can write 16 as 2 to the 4th, but 17, the only way I can do it is do 17 to the 1st power. So what I have to do is I can either take the log or the natural log of both sides. Since in the directions it tells us to use base 10 logarithms, I'm going to take the log of both sides. But technically, you can also do the natural log of both sides. So what I'm going to do is I'm going to have the log of 17 to the negative x minus 3 equals the log of 16 to the negative 8x. Now that they're written as logarithms, I can take the exponent and multiply it by my logarithm using those basic rules for logarithms. So negative x minus 3 times the log of 17 is equal to negative 8x times the log of 16. Now here, I want to solve this for x, and since there's an x on both sides, I'm going to have to use my distributive property. Otherwise, I'd probably just go ahead and divide by my logarithm, but I can't divide by my logarithm in this case because I've got x's already on both sides. So I'm going to use my distributive property. Negative x log of 17 minus 3 log of 17 equals negative 8x log of 16. Since I want to solve this for x, I want my terms with my x's on one side, anything without an x on the other side. So negative x log of 17 plus 8x log of 16 is going to equal negative 3 log, nope, not negative, positive 3, because I moved it over, positive 3 log of 17. So I had to add that when I moved it over. I also had to add that when I move it over. So what I can do here, since I've got x's in both my terms, is to factor just the x out of there. X times negative log of 17 plus 8 log of 16 equals 3 log of 17. Notice I took just the x out of both of those. To solve this for x, then, I can divide by this stuff here. So x is going to equal the 3 log of 17 over all the stuff here in the parentheses. Negative log of 17 plus 8 log of 16. And they don't want us to evaluate it, they just want you to use an exact answer. Otherwise, we'd have to use our calculator to evaluate approximately what that would be equal to. Number 17, again, we have a base 7 and a base 9. No way you're going to get those written with the same base, so we're going to take the log of both sides. The log of 7 to the negative x minus 7 equals the log of 9 to the negative 6x. Now that they're written as logarithms, we can multiply our logarithm by our exponent. So negative x minus 7 times the log of 7 equals negative 6x times the log of 9. Using our distributive property, negative x log of 7 minus 7 log of 7 equals negative 6x log of 9. I want to move my x over here, anything without an x over there. So negative x log of 7 plus 6x log of 9 equals a positive 7 log of 7. Going to factor my x out. So x times negative log of 7 plus 6 log of 9 equals 7 log of 7. I can then go ahead and divide. So x is going to equal 7 log of 7 divided by all of the stuff here. Negative log of 7 plus 6 log of 9. And one last one on here. Again, we have bases that can't be written the same, so we're going to do the log of both sides. So I'm going to do the log of 13 to the negative 6x equals the log of 3 to the x plus 5. So bringing my exponents out in front, negative 6x log of 13 equals x plus 5 times the log of 3. Using my distributive property, negative 6x log of 13 equals x log of 3 plus 5 log of 3. And since I don't like all those negatives, I'm going to move this one over here, so then I'm going to move anything without the x over here. So I'm going to have negative 5 log of 3 equals x log of 3 plus 6x log of 13. It'd be okay if you moved them the other way. Your signs will just end up being opposite of what I did. Factoring out my x. And then, of course, dividing. So, negative 5 log of 3 divided by the log of 3 plus 6 log of 13 is going to be equal to x. Now be careful when you type that in. That negative is up on top with the 5. Shouldn't matter if it's out in front, but just to be on the safe side, it's best if you hit the fraction button first, type that in. Now, that's all the logarithm stuff we're going to do. There is a lot more logarithm stuff that we could do, but just to give you the basics of logarithms, which you should have already done in college algebra, probably won't do a whole lot of logarithms in calculus, but still, you kind of have to know those basic things.